Welcome back, students. Now, in this lecture, we are going to discuss inverse function. Now, what is inverse function? Now, let's say we have a function f here. The inverse function is actually the reverse process of function f. So the function f actually map x to y. So the function f assign the input x to one input y. Now, the inverse function is actually assign the y back to x. All right, so we can see here the inverse function is actually the reverse process of f. So since the inverse function is the reverse process of f, so when we put these two functions together, so we will get back the x itself. Okay, so as we can see here, all right, the x, this x is here. First go through the function f, so we get the y, and after that the y go through the function inverse, so then we will get back the x. Okay, so when we put these two inverse functions together, we will get back the x, the input itself. Now please note that, all right, the range of f, all right, will become the domain of inverse function, and the range of inverse function is actually the domain of f. Now let's take a look on one example. Okay, now let's say we have a function f equals to square root of x minus 2. Okay, so from here we know that the domain will be x is greater or equals to 2. Okay, why? Because the value the value inside the square root, it has to be more than 0. So we know x minus 2 is supposed to more than or equals to 0. Therefore, the x should be more than or equals to 2. Right? So then the function of the graph of this function now will become like this. Okay, so start from 2, and this is the square root the graph of square root function. Okay, now first we need to determine that this graph is 1 to 1. Right? So only when the f is 1 to 1 function, the inverse function exists. Right? So you can see here now, if we have the x is here, then we get 1y. When the x is here, we get 1y also. Right? So when the x is here, we also get another y. So we can see here, this square root function is 1 to 1 function, and therefore the inverse function exists. Now, let's consider 1 to 1 function here. Now, when the function is 1 to 1, so we assign the x to y, and the inverse function will exist to assign the y back to the x. Now, if the function is not 1 to 1, for example here, okay, right, so this function is many to 1, right? So many to 1. So if the function f is many to 1, when we reverse this process, it will become 1 to many, right? When we reverse the process, now it becomes 1 to many, and we know that 1 to many is not a function. Therefore, if the function is not 1 to 1, the inverse function does not exist. Okay? So to determine whether the function is 1 to 1 is very important, because only when the function is 1 to 1, the inverse function exists. Now, after we determine the function is 1 to 1 function, then next we can actually proceed to the calculation. So first we let the y be the fx, and the function is x minus 2 square root. Okay, and we are going to find the x in terms of y. So we let the x be subject of the function. So we bring over the square root to y, so it becomes a square, and here we have x minus 2. So the x will be y squared plus 2. Okay, we're back to the diagram to see what happened here. Now, this is the x. After function f, we get the y. All right, now for the inverse function here, we try to find the x when given the y has the input. So the y is the input, right? So we find the x. Therefore, we will have something like this. The y has the input, and we are looking for the x. So in this case, since the y is the input, okay, so when we change the input to x, so we can change this one to x as well. So we have x squared plus 2 if we let the input be the x. So this is the inverse function we are getting. Right now, from the graph here, we know that the range of the function, right? The range of the function, the lowest y is 0, right? So this is the lowest value of y, which is 0. So the range will be y is greater or equals to 0. And the range now become the domain of the inverse, and therefore we put here x must be greater or equals to 0. So this is how we obtain the inverse